area of Appalachian State University in Boone, North Carolina. Flood previously served as director of the Digital Craft Research Lab at the University of Wisconsin-Milwaukee, and for 11 years served various roles in the Department of Art, such as Director of Foundations, area head of the Jewelry and Metalsmithing program, and coordinator for the BA in Digital Fabrication and Design. Flood is a graduate of the University of Illinois, where he received his Master of Fine Arts degree in Metalsmithing. Please join me in welcoming Frankie Flood.
Thank you, Deanna. Can everyone hear okay? Yeah? Okay. So today I'm going to take you kind of on a journey about how I've kind of arrived at the point that I'm at in my own artwork. And so today I'll be talking a little bit about digital fabrication and craft, and this idea of connecting craft and community. I've been intrigued by this quote by Jonathan Ive, who designed most of your phones and computers that you've used. He's a designer for Apple. And his father was a professor of metalsmithing in England. And so one of his most favorite days was on his birthday. His father would let him go in and make anything he wanted to make. And so he's intrigued and interested, if you couldn't tell by the objects that we use, by this idea of how things work and how things are made and how things are created. This is a picture of me when I was a little boy. My dad was a factory worker, but he would come home and he would often work on creating things, and they were just hobbies. He would start with making tools to make another tool. So we'd make a belt grinder to be able to make a knife out of an old file. And so this has had a huge impact on my career and the things that I'm interested in. Tools are one of those things, and this idea that a tool is an object that extends the will of the user. And I've really been interested in how we are surrounded by objects in our daily life, and we consume objects, but yet we're very uncomfortable with making sometimes from scratch. And so thinking about, from the very beginning of time, how tools have been used to perform specific tasks has been something I've been thinking about a lot. This is a belt grinder that I actually created, and I created it based off photographs from another belt grinder that was online, and made it so I could sand things with this horizontal sanding belt. And so I frequently couple my studio practice with making tools. This is another belt grinder that I created. And again, this was something that was instilled into me from my father when he would he'd find an old washing machine or something along the side of the road, and we'd take it home to gut it, to get the motor out of it, to then build something like this. And so here's a picture of one of my students using that belt grinder to make a knife. So beginning at age 14, I worked full-time in the summer months and then part-time during the academic year on a factory assembly line. And I worked in a factory that took raw material in and then created a product. And sometimes you didn't get to be a part of seeing what the end thing was. You were just doing a part of it. And I started to realize why my dad would come home and work on things, because he started to own the means of his own production. And I entered into graduate school after taking my first metals class as an undergrad and falling in love with it. And I started creating these bracelets that were self-sizing. You could actually unscrew the knob on it and it would loosen and tighten against the wrist. And these kind of resembled traction devices, right? Kind of like these prosthetics or traction devices you might see when a bone is reset. And I was basically teaching myself how to machine. How to use machining tools, because I had encountered machining at the factory and I was intrigued by, why don't I learn about this in college, in my metals courses? This is a dual function object. It's a tape dispenser and a bracelet. And this is reminiscent of this tape machine that I used to have to work on at the end of an assembly line. And you would have the product running down the line, right? And the tape machine would run out of tape. And then you had to lay on your back and you had to thread it through all these rollers. And if you didn't thread it in the right pattern, the tape machine wouldn't work when you shoved the first box through. But it was like that episode of I Love Lucy, right? When the chocolates are coming down the line and they're eating them and stuffing them. It's like, it's like that. And I was like, oh, it's so crazy. And so I thought this idea of making this ridiculous piece of jewelry that then also served a second function would be interesting. So I used to, like I said, hang out in the factory, and I'd go over on my breaks and hang out in the machine shop, and I'd talk to the people over there and say, what do you make when you go home? Because you've got this knowledge that is extensive in how to make things. And they'd scratch their head and they'd go, I don't make anything when I go home. I'm just kind of living for the weekend, And I was like, wow, what a shame. But I started to understand it was because in some ways they had separated what they do during the week with what they do on the weekend. And so again, I continued to kind of investigate this self-sizing bracelets, self-sizing jewelry. And so I started working with other materials like acrylic and aluminum. I was bringing home scrap aluminum from the factory and then remachining it so that it didn't have all the dents and the scratches in it, and reusing it. And it really culminated in the creation of a lot of work that, where I really was kind of teaching myself a new skill set and not really being reliant upon what I was being taught in class. And I would take these pieces into the critiques, and people would say, well, why did you spend all that time making that thing? Why does this object have to be so, so involved, And I couldn't explain at the time. But then eventually, as I started working through graduate school, I was like, why are people so opposed to skill? Why are artists in some ways, it has to be like, if it's skillful, it can't communicate ideas or something. So I was really struggling with that. And I started to think about this thesis that I would call the alienation of labor in art, and how we kind of alienate, just like the worker is alienated from the thing that they produce in the factory, that we kind of alienate, due to labor. I made this first pizza cutter called Easy Rider. This is a pizza cutter. A lot of people at the time looked at it and they said, well, how is that a pizza cutter? Like, I've never seen a pizza cutter like that at Target. And I said, well, precisely, that's exactly the point. Why can't we make objects and use objects that are unique and one of a kind? And so that really kind of spurred a whole idea around this idea that in some ways the objects that we consume are meant for impersonality, right? And the first thing you do when you go buy a new cell phone, you go out and you probably purchase a cover, right? And then you probably put a few stickers on it, right? Or if you go get a car, you usually maybe want to put some new rims on it, right? Or a different stereo system to make it your own, right? And so I started to realize that there are a lot of subcultures, like biker culture, that kind of embrace this idea of creating something one of a kind, something with aura, right? And I started to research this idea of, conforming, and the fact that, after World War II, there was this level of conformity. Everybody had to have 1.2 children, or whatever it is, and they had to kind of like prescribe to a certain kind of lifestyle. And I was really intrigued by these like motorcycle and biker culture, subculture, because it was this idea of freedom to be able to do this thing, make this thing. And I actually see this as a big piece of jewelry that you get to ride down the road on, right? It's like it's a functional piece. You become one with that thing. And it reminded me of working in a factory where I would see these workers who actually on weekends what they were doing is they couldn't wait to work on the car or the motorcycle or a special project, a piece of furniture they're restoring, right? And I was like, wow, okay, that's people's response to that daily grind. And so I thought, I've got to make some more pizza cutters, and I've got to kind of work this through the object, through making these objects. This is PFL, Pizza for Life, machined out of aluminum, stainless steel. It's all manually machined. None of this is computer machined. It's literally taking a template, gluing it down on metal, and cutting it out, right? And then doing some machine work on the lathe to kind of refine the form. This is Fat Boy. And again, I was really interested in using different materials like carbon fiber and powder coating, and thinking about kind of this just over ornamentation with these like 50 microbolts on one side and 50 microbolts on the other to hold the blade on, And this is PFL Mantis. So just thinking about how I could refine my machining skills too. I was trying to like think about that. And this is gold knuckle. So it's black powder coat with gold-plated brass. And so one of the next pizza cutters I did, this is a chopper builder in Florida at the time named Billy Lane. And he, a lot of times you'll see industrial designers especially, they'll design objects, vehicles especially, that have a hubless wheel where you can stick your hand through the wheel. And they always design, they always look amazing, right? But you never see anybody actually ever execute one of these designs, right? But it was interesting. He took a rotor bearing, or a bearing out of a rotor of a helicopter. He started with that and decided that's going to be my rear wheel, so you could actually see right through the wheel while you're driving it down the road. And I thought, that's really cool. I'd love to make like a hubless pizza cutter. And so I found this old bearing that was very thin but large diameter, and I took it apart to figure out how it worked. And then I basically measured the specs on it and reduced it down on my own in raw material to make my own bearing. So basically there's a little brass ring, and you pop that brass retaining ring, and then you can slide all the bearings on one side, and the inner and the outer race fall apart. And so that became Psycho Pizza Cadillac. So kind of a response to that Johnny Cash song, right? The one piece at a time brings the car home, and the lunch box. I don't know. I may be beyond. So I may be showing my age here. So all the pizza cutters have these suspension, right? These shocks, and so again, just thinking about how tools and this usefulness grew out of instinct, and again this kind of smashing of conformity. I was really interested in that with the pizza cutters. A lot of people want to come into the critiques with the pizza cutters. They say, well, you could never use it. I'm like, no, you can use it. Oh, you could never wash. Yeah, you can wash it. You can totally wash it. But people weren't willing to accept them as functional objects. And I was like, why not? And I realized it's because they're not used to using or seeing something that's truly unique. So I thought, I've got to build something to go along with that. So I decided I was going to build a chopper motorcycle to kind of bring the relationship in an exhibition together. So I started off with this old Triumph motorcycle, and I made an English wheel. This is a tool for rolling metal into compound curves. Panel beaters in England used to use these all the time to make cars. So all your old Jaguars, early Porsches in Germany were hand-hammered aluminum and then rolled to create the shape. And so I made it, actually that bearing was out of an old printing press from where my dad worked. And and then I made a gas tank, and I took a welding class in this School of Architecture because I really wanted to learn how to weld really good, really well, right? Because in sculpture it's kind of like, oh, you just take this, you stick it together, it's done, right? But I really wanted to learn like all about it. So I took this class. I said, if I can build the tank, and I think this was like I think it was about this time of the year that I started to build it, and my thesis show was in the next semester in like March. So I made a leather shot bag, turned a wooden hammer for a hammer to be able to beat out the shapes. I made templates off of the tank. I made the gas tank, and then I was like, okay, I got this far, I'm going to keep going. And I started making the foot pegs, and I built like the front end, the Springer front end, and the fender, and the foot controls, and the pipes, and basically assembled this thing in my studio. And then eventually showed it in my thesis exhibition along with the pizza cutters. So that kind of started this idea of like, okay, how do I just like teach myself how to do these various things to be able to create what I want to create? And while I was in graduate school, I'd taken some classes in CAD. We learned how to use AutoCAD, and I thought, well, this will be a great tool for me to basically be able to visualize what things look like before I build them. Right? In the beginning, I was just modeling things I'd already made, and I like the fact that you could duplicate, copy, and paste, and you could apply materials and lighting to an object, and you could animate it. That was cool, right? And I could see how something was going to function before I built it. And I was like, okay, that could really, come in handy for me to be able to like use this to visualize things before I spend, an exorbitant amount of time making them. But at the time, there was not much you could do with those digital files. And I kind of went on the back burner for quite a while. I mainly used it to create templates for cutting out things. I got a job at the University of Wisconsin, Milwaukee, teaching metals and also in foundations. And I started teaching, courses. And in this particular case, I always do a tattoo assignment with my students in their intro class, because I think tattoos and jewelry have similar functions throughout history in terms of what they mean: significance, commemoration, self-expression. And so it's a great parallel for me to be able to kind of pull together for students to understand the history of jewelry. Because they understand, you guys understand that tattoos, right? You totally do. I also started teaching a class called Industrial Processes, which was basically a class that focused on what I do in my own work. Basically take industrial processes, shrink them down to a studio level, and then use it for your studio practice. So you learn how to machine on a lathe and a mill and stuff like that. At the same time, I became really interested in creating three-dimensional forms from data. And I'd gotten a little tabletop CNC milling machine, and I was going around campus and pulling off the push plates that you'll see on doors on institutions, and I would bring them back to my studio, and then I would engrave them with my machine, and then I'd put them back, right? And I was really intrigued because in Milwaukee you'd see a lot of, there were a lot of beer companies, right, that had existed in Milwaukee, and they would hire like there was a metalsmith named Cyril Kolnick, and Cyril built a lot of the decorative gates and doors and stuff around the area. And I thought, man, our areas are so devoid of ornamentation now. And so if I can sneak a little ornamentation into the institution, that's kind of cool. And so it was kind of a fun project. And I was cutting my teeth, basically, learning how to use a CNC mill at that time. And I was really starting to question, like, what does all this mean, like in terms of 3D printing? Like, what does the future mean for someone like me, who I really enjoy making that one of a kind? But what happens when you can pump out 500 of this thing in a piece, plastic, let's say? And I was like really struggling with it. But I thought, I'm going to move forward. I'm going to take some of my other designs, kind of, 3D print those. And it was funny, the school at the time, I said, I think we need to get into 3D print. I'm not sure why, first of all, because it kind of goes against what I'm thinking in my own work, but I think it's important for our young people to learn this. And they said, well, we don't see any value in it. I think this is many, many years ago. And I said, okay, well, that's fine. I said, it'd be kind of cool to still introduce them to this. So I called a company, and I said, a local company that distributes 3D printers and laser cutters. And I said, hey, we're building a new lab, a new digital fabrication lab at our school. And they were like, that's great. They said, we'd love to show you our machines. I said, oh, really? Could we get them for a trial period just to test? Yeah, we can do that. So I got them for basically to agree to a month that we could keep these in our studio and we could use them, and I could get to learn how to use it, and then I could show the students and we could make some stuff, and I could kind of get a sense of like, is this something we want to do or not? They didn't know I didn't have the money and I didn't have the approval and I didn't have the space, but it let me do what I wanted to do, right? And so I got to print and I got to test these things out and I got to make a series of this piece that I'd made before and kind of compare them, like what's the difference between this and that, right? And so I continued to investigate CNC machining, thinking about creating objects from data. So basically this is a little tabletop mill. The way it works, you put a piece of like a block of material in here, and then there's a cutting bit, almost like a drill press. It's called an end mill instead of a drill bit. And the end mill subtractively carves away because the machine is controlled by motors here on the X, here on the Y, and there on the Z. So you can start with a block of material. That's strange. Where's my thing? Oh. Okay. And you can take and basically subtractively carve an object, and it will reduce it down to a form. And then I'm still using a CAD program at this time to kind of like be able to model. Let me see if this will play the video. So there's a program that I use that's a CAM program, and basically that CAM program shows you what it's like to model an object, and then you actually subtractively carve it. It's not showing up, but that's okay. We'll go ahead, go forward. So I started off machining in pink foam, and pink foam allowed me to like test out things, and I could also then later on cast from that if I wanted to. But basically the idea is that you're subtractively carving this object, reducing it down almost like tiers of a cake, and then refining the form. And eventually that form winds up in the form of a wheel for a pizza cutter. And then I can anodize it, and I can start to make multiples, but then I could actually then just use surfacing techniques in terms of anodizing in this case to change how one looks versus the other. And I continue to do a lot of commission work as well. I get a lot of requests for pizza cutters, and it really, in some ways, allows me to keep like exploring materials and process. As I was working at UWM, I got asked to do a Chancellor's Medallion. And so this was a case where I really started to use what I'd learned in CAD. So I could go in and talk to him. I said, do you like this link style, or do you like that link style, or do you like this link style? And he was able to visualize. And I started to realize, wow, this is really important for my students because they can use this as a tool to communicate with a client and say, hey, this is what I can do. This is what I can make. And so this actually there's a map of campus. This is a three-dimensional map of campus. It's extruded from the map that you get when you visit a school. And basically you rotate this map, and then turns this iris on the back of the piece that says UWM and it reveals the chancellor's name on the inside. And so I worked on this project, and we machined in wax the medallion form on my milling machine, and we machined a lot of components. We also 3D printed just to test, but the resolution was not good enough for my liking. But then we were able to really visualize all these components and bring together the design. It's probably, 20-some pieces in just the medallion. And that's not counting all the little, bolts and nuts. Each chain link has close to 7 or 8 pieces. Yeah, there's a lot of pieces.
From the get-go, it's really important to us to kind of get away from kind of antiquated, traditionalist ceremonial objects that really kind of have no relevance.
Lots and lots of sketches, heaps of ideas that ranged from literally, making a video of a fake medallion in 3D and then hanging a video screen off of his neck.
How can we use current technology to actually make the piece and again represent what we're doing at UWM?
At one point we realized that the campus map could actually be pretty interesting, and there's a lot we could do with it rather than just kind of a snow globe model city. We could really stylize it. And working originally from the same map that you would get in a student brochure, we kind of created this little 3D world. So here you could see like Maryland Avenue, this would be the Union, this would be Engelman Field here.
The inspiration from this was taken from ball bearings, actually. And so we were looking a lot at the history of Milwaukee with industry and how bearings and heavy machinery and gears really played a huge role in Milwaukee's future as an industrial city. And we're actually kind of embracing industrial technology, where we're taking the processes of an industry and applying it to this kind of art object. We're also taking industrial materials. We're not working with gold, we're working with aluminum. We're working with brass. We're working with cheaper materials, but those are materials that you typically would see in industry. Basically, everything will be cut out with this machine or a larger CNC machine. A lot of people have this misconception that when it comes off of here, it's done. Like the machine does it all for you, and it doesn't. It's just merely a step in the process. The three-dimensional map of campus that Brian modeled, that's probably going to be the most time-consuming because it's like the most detailed. So we're going to cut it in wax and actually cast it.
Actually, it was all Mike's idea. I think it was in his head that, well, there's no medallion, the art faculty has to do it, of course.
Jewelry has this capacity to communicate ideas about the wearer, and so we really wanted to make sure to make it very specific to this university and this chancellor.
And speaking of the chancellor, his own PhD was actually advanced research on ball bearings. And so to have ball bearings as part of the chain as he's wearing it also, to me, is a nice touch, a nice personal touch.
Right now I'm just I'm melting aluminum in a crucible, and we're getting it molten. You can see how fluid the metal is, really moving. You can see the machining lines in that. We've got a lot of flashing here, but that's, essentially the map of campus, right? It's not as nice as we'd hoped, but we got the detail we wanted, so it'll be workable.
This is a big deal for me, to work on this before I've even graduated.
I think that's pretty cool. I like that I can be a part of it, I think that's pretty awesome.
You guys have been working really hard on getting these things together and soldered and polished over the last couple of weeks, so.
It's coming together, thanks. I can see that he's gonna have a smile on his face when he puts it on.
The students being a part of that, that's probably one of the best parts, because you see it, they're so excited in it. It's about, being able to be a part of it. The students have just polished these, and we're gonna take these, run them through a process called anodizing, where we actually open up the pores of the aluminum so that it can accept dye, and that will give them their final color. It's gonna really pop. Excited.
think there's so much actually thought that went into the medallion. That's what, as an artist and designer, I appreciate all the minuscule aspects and the ideas that went into it.
The students that we're educating are gonna shape the future of the city, and so the medallion, to me, I think it represents that, because we are using technology and we are using techniques that are not typical for this type of piece.
I think just the opportunity for people who are at this university at this time to have an input and actually design and make this object, I thought was really terrific.
We've been working on it for about 4 months. We wound up with around 86 parts in the chain. And we have probably over 120 in the medallion. We have probably close to 1,000 hours total, quite a bit of time. Probably one of the most involved pieces, you know, and sophisticated pieces that I've made. So I hope it's everything that he expected and maybe some more. So I had to try it out, right, before I gave it to him. So this was a fun project to work on. Again, you know, one of the things that was probably the most impactful was actually attending the ceremony. I talked to my students a lot about the power of jewelry, about the power of the things that we wear, the things that we use. But it wasn't until I actually saw our chancellor actually give a speech and talk about how that object represents the future of the university, and then to see it as a part, play a major role in that ceremony as he wore this and symbolized his kind of step over into being a chancellor. That's when it kind of like, I was like, wow, all those things I've been preaching, right? Like to my students, like it kind of like, I saw it like firsthand. And it was interesting. I designed and built that podium piece too, and then they had remodeled the entire auditorium. I built all these acoustic covers for the floor as well when they put in new seating. It was a crazy summer leading up to that. Since then, the chancellor has asked me to do several kind of gifts. These are actually given out to donors who donate $1 million to the university. And so these are actually 3D printed in metal. So I took that design and actually created that. I took some of the early CAD drawings, transferred those to laser cutter, so I can actually engrave these in black corian and then fill it with gold ink and then peel that back so we can get that result. And then I actually laser engrave gift boxes as well that go in, on the outside with the chancellor's logo. And so these, I made 10 of these, I think, to give out to donors, and they've given those all away. While I was doing this work, I was really thinking, and kind of like there was a period of time where I was thinking about this idea of the Digital Craft Research Lab. This place where people go to collaborate, work on ideas and people from different backgrounds, engineering, health sciences, art, design. And so I started building through the support of a local foundation in Milwaukee, and I was able to build this lab called the Digital Craft Research Lab. It's made up of 2 rooms, one where there's a computer lab with modeling tools, also just workspaces, just benches, dirty space, and then also across the hall a dirty space that contains tools, equipment. I started building this lab because we had a very small budget, and I said, you know, I'm going to use the same approach that I do in my own studio. I'm going to build the tools myself. So I built the CNC router with the help of one of my graduate students from a kit. We started building all these tool boards, and then we put a cleat system up, and I basically slowly started building this. I'm going to talk about this more on Friday with a group about how this all developed, because this is kind of toward the end. I built my own 3D printers. That's something I had been doing, but ever since the school had said, we're not going to buy you printers, I said, well, I'll build my own printer then. And I started actually I had built 2 or 3 printers before this one, but this became our little workhorse that I taught my students how to build their own printers with that printer. So that printer started having children, and we started getting a little bit of support from the faculty and from the administration when they saw some of the things that we were doing. And so I built these kind of 2 large spaces. And it became such a thing that the school said, we really should start a digital fabrication degree. And I was a little like, I don't know how I feel about that. Because like, to me, it's just, you just incorporate it into wherever you need to use it. It's just a tool. It's just, I mean, everything was technology at one time, right? That torch that I use, that was technology at one time. So I was like, I got to think about that. But we were doing things with 3D scanning. We're actually using the Xbox 360 Connect. You guys can, if you have one of those, you can actually use that to 3D scan with. And we were, you know, again, a lot of my graduate students, like Brian and Sarah, were kind of reaping the benefits of some of the things that we were doing because they were intrigued at how to incorporate this into their work. I became very interested in how do we combine traditional methods with new technology, and how do we reinvigorate some of the old processes that we do with the use of technology. It wasn't that we were going to use a 3D printer and make this thing and then it ends there. It was, we're going to, you know, use this 3D printer. This was a little Starch Z-Corp printer I bought. It's amazing. McMaster-Carr, if you don't know them, you need to check them out if you're a maker. McMaster-Carr actually has a catalog of their parts, right, that you can buy from in Chicago. But they actually went one step farther. They make 3D models now of a lot of their parts. So you can go download a model. And I said, yeah, I want a wing nut, right? Now, McMaster-Carr, I could have it next day if I ordered it by 5 o'clock. But if I want to go to my 3D printer, I can actually print that part that I've downloaded. I could make it larger if I wanted to, print that part out, right, in about 30 minutes, 30, 45 minutes. I make a traditional sand mold around that part, pack it with sand, drill a hole basically for a sprue, create my button, put it back together, align it, heat my metal up, pour it in, voila, part, metal part, functional part, okay? Probably within about an hour and a half, okay? Pretty quick, a little faster than lost wax. Quite a bit faster than lost wax. So I'm able to then make this part that I want from a catalog download that I've altered, printed, and made in real material, okay? That's the future, okay? So I still got requests for pizza cutters. I got this email with this, and I was like, well, that's kind of weird. Who would do that, right? And come to find out, this guy is on the show Top Chef on Bravo. He's been on 3 seasons, I think. Mike Isabella is his name. And he's like, I opened a new restaurant in D.C. called Graffiato. I got a tattoo of your pizza cutter, part of it. And he's like, I want that pizza cutter. And I said, oh, cool. I'm going to do it, but I'm going to make it look better than what the tattoo artist did, all right? And so I made that for him. So again, it's been interesting to see, like, you know, some of the functional objects I make, like, people are starting to appreciate them on that level. And then it's great to watch the show and then see his tattoo. Pretty awesome. I've been exploring this idea of machines that make through various low-tech and high-tech things, such as maybe a hand drill that we make, that we create, that is, again, has aura, has a unique quality to it, as well as to high-tech things like these RepRap 3D printers. And so these are some of the first printers that I built using a very basic circuit board, an Arduino or Sanguino, a heated bed, which is basically a circuit board, a hot end nozzle, which is basically a glorified hot glue gun, and you construct this thing out of basic hardware, and then you're able to create these pieces. And it prints pretty quickly. And so I was able to produce more parts for more printers. I started going crazy building printers. I would just build one printer after another printer after another, and just kind of, again, let it have children. And we make gears for it. This is one of my, Brian Sarah, who I pictured earlier, this is one of his printers. So my graduate students started building printers. To me, it was empowering for students to be able to leave the school with their own machine, right, that they can start to prototype with. I started investigating things like called Delta printers. These are basically not your typical Cartesian X, Y, and Z pattern. They're really beautiful. They almost dance when they move. So this one's just touching off on its limit switches, and it starts printing. One of my colleagues I now work with at Appalachian State actually has converted one of these to extrude clay. So it prints in clay. He's got some beautiful objects. If you're interested, I could give you his contact information later on. But it's amazing to see what people are doing where they're actually learning how the machine works to then adapt it to their own needs, not letting the machine dictate what you make, right? So I put a pen in it. You can do drawings with it. So all of this is happening, and I get this request from someone that their little girl was born with no fingers, and they wanted to know if I could make a hand for her because she'd seen this video. And I'm really interested in the idea that our village, like when I was a kid growing up, I lived in a small, small town, and when your neighbor needed something, you helped them. You loaned them something, right? You pitched in and you you shared resources. And it's interesting, our village has shrunk now thanks to the internet. We live in a global village. So I want to show this if we can. I know we're running short on time.
Can you just slide your hand through there? Perfect. Can you grab my hand with it or not? Oh, wow, that's pretty cool. Do it one more time. Ah, cool.
I said, I've got to do something because this is, I can help.
So you want to try it out or not? Yeah? Okay.
I saw all those videos of kids picking up stuff and I thought it'd be cool.
That's good.
I tell all of my students that we can change the world. We can do something important. We can do something impactful. And they come in and they're just ready to jump in and try something new. And
Shay and her class have come and visited our class, and we get to talk to her and interact with her, and it's really cool to see her put on the hands that we've designed and use them and really react to that.
What I really want to do is to streamline everything and make it so it's actually the same size as her other hand. So it feels like it fits. It's a functional part of her body.
I knew that they would come up with better ideas than I could come up with, because that's what our young people and our students do here at UWM. They come up with ideas that are grand, and that brings a richness to the project that I can't. I'm too old in some ways to do that, to have a fresh perspective.
none of the students have ever 3D printed, none. And so that entire production process is different. None of them have ever used a foam cutter. So it's a really fun thing to see them all out of their element, but willing to work together and help each other.
There's a Google Plus community called e-NABLE, and e-NABLE is a group of right now about 400 members. So I can talk to people from around the world. I can download the files for it.
We had our students join e-NABLE, and almost immediately people who I would be intimidated to talk to at first, would chime in on their sketches and their ideas. And the students, you could just see they came in and they were proud of the fact that they were part of this. And I think that that's really empowering.
I think that just that rapid pace at which we can develop and research, it's wonderful, it's marvelous.
Pull them out and stick them on the finger that you want them.
I don't think there's a lot of other kids out there who can say that they get to be a part of making their own hand and give feedback and can have choices. Just seeing her joy. As a mom, that's all you want, is your kids to be happy.
Have you ever seen the laser cutter work? It's pretty fun.
They're the ones that can sit here and spend hours and hours and hours away from their family working on stuff. It's just absolutely incredible. Absolutely incredible. So leaves us speechless.
Is that too tight? Are you okay? Is it okay? Okay.
Yes, Frankie and I are giving them these hands, and sort of we're gifting them with our work, but I think in a real way, they are giving us the bigger gift. This is the type of opportunity that lets you re-fall in love with a discipline. Would that be cool? Put little charms in there.
There's so much more we can do. There's so many more problems to solve. Being here and being able to engage with our students to do that, that's the greatest job in the world,
All right, I know we don't have a lot of time. I'm just going to talk a little bit about this project, and I'm going to talk more about this on Friday at a talk, and then a little bit more tomorrow as well. This is a project where I started to realize, wow, we as artists and designers, we have the ability to synthesize material and process in a way that others really don't. And we can use those talents and those gifts, those abilities, to do something far larger than ourselves. And that's what I've been focused on lately. And so I'll leave it at that, otherwise I'll get choked up. But sorry, my goodness. But we've made a lot of hands for other kids. And Man, very strange. This is Bella. That earlier you saw Karuna. This is Evan. Evan was actually an amputee. He's the first child we've helped that wasn't born with amniotic band syndrome. Anyway, look at the video, won't play, but he was in an accident and we had to have his hand amputated. So we've made a hand for him. You know, this came about from a couple people, Richard Van Az and Ivan Owen. Ivan Owen actually later on, it was funny, we've worked together a lot. We've collaborated on different designs. This was the first design. Ivan actually became a member of e-NABLE as well, which was spawned kind of from a video that MakerBot had done. And again, e-NABLE has grown into a huge community. I'll talk more about that. I've helped kids from as far away as Inverness that I've never met. This is Haley from Inverness. BBC did a segment on her, but she's able to use her scooter. She's able to pick up things. And again, we did this all from a drawing and a little plaster cast that she sent to me. I'm able to send her 2 hands back. And yeah.
In the United States of America, and he kindly made a 3D printed hand for Haley, free of charge. As Haley was born with her small hand, it's never ever stopped her doing day-to-day tasks. However, with her new prosthetic hand, she can pick up heavier objects such as fruit or teddies, and it also can give her counterbalance when she's riding her scooter. Before Haley got her hand, her options to her were to have a toe removed from one of her feet and put on as a finger on her left hand so she can have a pinching action. However, it wasn't an option to us to put her through that as she was so young at the time. So now we've looked into helping other children in the United Kingdom.
Did you hear that? We're looking into helping other children in the United Kingdom. That's the cool part. They're now reaching out and helping others. So they're passing it on. And so again, it's pretty amazing. I'll talk more about this. Students have gotten involved with this in my lab. We've presented this work at Johns Hopkins. I've actually collaborated with some of the other designers in the e-NABLE group to design this hand called the Raptor. We've actually sent this out to other people for them to print. And then the kids have come and we've actually helped them and their families by doing demonstrations and let them build their own hand as workshops at Johns Hopkins. And so then they actually get to partake in making, right? Firsthand, literally, to be able to create. Sorry, that was not intended, but seriously. But it's really amazing to see then the impact of that. So I'm going to leave it at that. If you're interested, later on I'll give a talk on Friday. If you have any questions, I'd love to listen. So thank you.